Hello friends, I welcome you in lecture number 43 on double integrals. In this lecture we will discuss this question which is on the change of variables formula. This question was asked in GTU winter 2015 exam. Here we are asked to evaluate this double integral which is in terms of x and y by applying the transformation u equal to 2x minus y by 2, v equal to y by 2. And we are also asked to draw both the regions, that is we have to sketch the region of integration in xy plane as well as region of integration in uv plane. So first we can write the given region of integration in xy plane, so that we can decide from the given limits. Here order of integration is dx dy. Therefore, these are the limits for variable x and these are the limits for variable y. So, we can write that in given integral, the curves are in given integral, we can say that x has limits x equal to y by 2 to x equal to y by 2 plus 1. And limits of y are from 0 to 4 and y equal to 0 to 4. So that means region of integration in xy plane is bounded by these four lines: x equal to y by 2, which is line passing through origin, x equal to y by 2 plus 1, y equal to 0 and y equal to 4. And here it is asked that we have to sketch or draw both the regions. So first we sketch the region in the xy plane. For that we can find out the intersecting points of all these curves. For example, if we take y equal to 0 in x equal to y by 2, we can say that y equal to 0 and x equal to y by 2 will intersect at origin 0 0. Similarly, if I take y equal to 4 in this, I will have, if I take y equal to 4, I will have x equal to 4 by 2, that is x equal to 2. So x equal to y by 2 will intersect y equal to 4 at point 2 4 and it will pass through origin. Similarly, if we take y equal to 0 in this line, x equal to y by 2 plus 1, if we take y equal to 0 in this equation, x will be equal to 1. So x equal to y by 2 plus 1 will intersect y equal to 0 at this point 1 comma 0. And if we take y equal to 4 again in this equation, first we write y equal to 4. So if I take y equal to 4 here, I will have 4 by 2, that is 2 plus 1, that is 3. So this line x equal to y by 2 plus 1 and y equal to 4 will intersect at point 3 4. So it is better to decide the points of intersection for given curves so that we can easily sketch the region of integration, and we can decide appropriate scale also. From these four intersecting points, we can say that maximum scale on x-axis required is 3 and maximum scale on y-axis is required as 4. So now we sketch this region of integration in the xy plane. We have to find out the region of integration bounded by these four lines. So suppose this is xy plane and we will roughly consider this distance is say 1. Suppose this distance is 1, then this is 2, and we require maximum distance on x-axis as 3 and maximum distance on y-axis required is 4. So we can roughly decide that this is 1 2 3 and 4. This point is origin, and another points are 2 4 3 4 and 1 0. 1 0 means here this is x-axis, so y equal to 0. So this point is 1 0. Then we have to sketch 2 4 and 3 4. 2 4 will be here On y-axis we have to go up to 4, on x-axis we have to go at this point. So this is approximately 2 4, and this distance is 3, so this point is 3 4, and all the curves are straight lines, so we can easily sketch them. So let me use another color. Okay, fine. So once we write down the intersecting points, now we can see one curve is y equal to 0, that is x-axis, then x equal to y by 2. X equal to y by 2 will pass through 0 0 and 2 4. So we can join these 2 points 0 0 and 2 4. So this is x equal to y by 2. So here I can write that this is the line x equal to y by 2, and x equal to y by 2 plus 1 will pass through 1 0 and 3 4. That means these 2 points. So we can sketch those 2 points, 1 0, this one and this one. So and y equal to 0, that is x-axis, and x equal to y by 2, and y equal to 4 is also required. So y equal to 4 means line parallel to x-axis, and it will pass through this point 3 4 and 2 4, and from this point also. So it will pass through from these points. This is the line y equal to 4. If we wish, we can extend these lines also, and this also. But we are interested in the region which is bounded by these 4 lines. This line is x equal to y by 2 plus 1. This is y equal to 0. This is y equal to 4. And our region is x is from y by 2 to y by 2 plus 1, that is from this line to this line, and y is in between 0 and 4. So the region of integration is this region. This is the region of integration in xy plane, and we are asked to draw the regions in xy plane as well as in UV plane. Therefore we must sketch the region of integration. This is y-axis, that is x equal to 0. So we should write all the things. We should we must specify the equations of the curves. We just not sketch the lines, we should specify that this line is for y equal to 4, this line is for y equal to 0, this is for x equal to y by 2, and this is for x equal to y by 2 plus 1. So this is the region of integration in original variables x and y, or region of integration in xy plane. Now first we use this transformation u equal to 2x minus y by 2 and v equal to y by 2, and we find out the region corresponding to this region in the UV plane. So for that we can first write the transformation. Given transformation is, we are given that u is 2x minus y divided by 2 and v equal to y by 2. Using this transformation we will decide the curves corresponding to all these curves. Suppose I consider x equal to y by 2, then this I can rewrite as 2x equal to y, that means 2x minus y equal to 0. And if 2x minus y is 0, we can say that 2x minus y divided by 2 is also 0. And if we use this, 2x minus y by 2 is nothing but u. We obtain that x equal to y by 2 will be transformed into u equal to 0, that is v axis in the UV plane. Similarly, we can decide the curves corresponding to each curves in the xy plane. X equal to y by 2 plus 1. If I multiply this whole equation by 2, I will obtain 2x equal to y plus 2. This gives me 2x minus y equal to 2. And from this I can rewrite this as, if I take this 2 on this side, I will have 2x minus y by 2 equal to 1, and 2x minus y by 2 is u. So this is converted into u equal to 1. X equal to y by 2 plus 1 is converted into u equal to 1. X equal to y by 2 is converted into u equal to 0. Then another curves are y equal to 0 and y equal to 4. For that we can use this v equal to y by 2. So suppose I consider y equal to 0, I can say that y by 2 is also 0 and y by 2 is v. Therefore v equal to 0. Y equal to 0 will be converted into v equal to 0, and y equal to 4 will be converted into v equal to 4 by 2, that is 2. Y equal to 4 implies y by 2. If I divide both sides by 2, I will have 2. This means v equal to 2. So v is from 0 to 2 and u is from 0 to 1. So we can observe that limits of all these regions are, we can see that x equal to y by 2 plus 1 is converted into u equal to 1. This is transformed into u equal to 1. X equal to y by 2 is transformed into u equal to 0. That means u is from 0 to 1. We are having constant limits. Y equal to 0 is converted into v equal to 0 and y equal to 4 is converted into v equal to 2. Therefore, the region in the UV plane will be the region bounded by these 4 lines: u equal to 0, u equal to 1, v equal to 0 and v equal to 2. That means we are having the rectangular region. All the limits are constants. So we can write that the region in the UV plane is bounded by u equal to 0, u equal to 1, v equal to 0 and v equal to 2, and we can easily sketch this region as shown in following figure. So we just have to sketch the rectangular region, and for that let me use appropriate scale. So now we are sketching the region in the UV plane. We have to consider u axis and v axis instead of x and y axis. Here we have u axis, that is v equal to 0, and here we have v axis, that is u equal to 0. This point is origin, u equal to 0, v equal to 0. Now maximum scale on u axis required is 1, maximum scale on v axis required is 2. So suppose this distance is 1, so this point is going to be u equal to 1, v equal to 0. This is suppose 1, so here we have u equal to 0, v equal to 1. This is u equal to 0, v equal to 2. So first we sketch u equal to 0. U equal to 0 is the line which is v-axis and u equal to 1 is the line passing through this point and parallel to v-axis. So this is the line u equal to 1, this is the line u equal to 0. So u is from 0 to 1, v is from 0 to 2. So v equal to 0, that is u axis, v equal to 2 means line passing through this point and parallel to u axis. This line is v equal to 2 and this point will be, here we have u equal to 1, v equal to 2. So this is the region in the UV plane and it is rectangular region. So limits of integration for u and v are u is from 0 to 1, v is from 0 to 2. So our integral will be converted from integral over non-rectangular region to integral over rectangular region. So another thing we have to do is we have to find out the Jacobian, because we are applying the change of variables. So now we find out what is the Jacobian. J of variables x, y with respect to u and v. By the definition, this is equal to determinant with first row as partial derivatives of x with respect to u and v. Second row is partial derivatives of y with respect to u and v. So this is the determinant. Now we are given the formula for u and v. We are not given the formulas for x and y in terms of u and v. So instead of finding this Jacobian of xy with respect to uv, we find out Jacobian of uv with respect to x and y, because we are not having expressions of x and y in terms of u and v. So I first find out this, and this Jacobian we denote by j dash. So here first del u by del x, del u by del y, del v by del x, del v by del y. Now we are having formulas of u and v in terms of x and y. U is given as, let me see what is u. U is 2x minus y divided by 2. Del u by del x will be 1 by 2 minus 0, that is 1. Del u by del x is 1. Then we have to find out del u by del y. So again this 1/2 is constant, derivative of 2x with respect to y is 0 and derivative of minus y with respect to y is minus 1. So we will have minus 1/2. Del u by del y is minus 1/2. And v is given by v equal to y by 2. So del v by del x is 0 and del v by del y is 1 by 2. So now we evaluate this determinant. 1 into 1/2, that is 1/2 minus 0. Therefore we obtain that j dash, that is Jacobian of uv with respect to x, y is 1 by 2. And we are interested in the Jacobian j of Jacobian of xy with respect to uv, and using the property of Jacobian we know that this is given by reciprocal of j dash, that is 1 over j dash. So we consider 1 over 1/2, that is 2. Therefore Jacobian is 2, and if we consider absolute value of Jacobian we will obtain 2, because 2 is positive. Now we have everything whatever is required to convert the given integral from x, y to uv. So now we apply the change of variable formula. For that, first we write down the given integral. Given integral was integral of 2x minus y divided by 2 dx dy. X is from y by 2 to y by 2 plus 1, y is from 0 to 4. This is converted into, and we can see that this 2x minus y by 2 is equal to u, that is given in the transformation. So 2x minus y by 2 will be replaced directly by u, and dx dy will be replaced by absolute value of Jacobian times du dv, and in limits of integration are u is from 0 to 1, v is from 0 to 2. Here we have 0 to 1 and 0 to 2. These are the limits of u, these are the limits of v. So this double integral in terms of x and y was over non-rectangular region, and using the change of variables formula, this integral is converted in terms of u and v and over the rectangular region. So we can easily evaluate this integral. Before that, we put the value of Jacobian. Jacobian is 2 integral with respect to u and v. U is from 0 to 1, v is from 0 to 2. We can take 2 outside integral, it is constant. V is from 0 to 2, and if we integrate u with respect to u, we have u square divided by 2. Limits of u are from 0 to 1. Then we will integrate with respect to v after putting limits of u. V is from 0 to 2. Upper limit is u equal to 1. So we obtain 1/2 minus 0, that is 1/2. And this 1/2 will cancel out with these 2, and integral of dv is v, and v is having limits from 0 to 2. So finally we obtain that this is equal to 2. So in this way we can evaluate the given double integral by using the given transformation. So here you can see this region in the UV plane is rectangular region. It is easy to integrate in rectangular region as compared to this type of non-rectangular region. Here you are asked to draw both the regions, but suppose this is not specified, then it is not necessary to sketch the region of integration, because we can see after applying the transformation the limits of integration are constants. The boundaries which we obtain corresponding to curves in xy plane, all the boundaries are lines, and lines parallel to u axis and v axis. That means we are having constant limits for u and v. So if we have constant limits for u and v, then it is not necessary to sketch the region of integration. We can directly integrate. But if it is specified that you have to draw both the regions, then you must sketch both the regions of integration. Otherwise you will lose marks. This question is asked for 7 marks. So you should take care of this. Otherwise this is very easy. You just have to remember this formula, that suppose our double integral is in terms of x and y in the xy plane over region R, then after applying the transformation, x is some function of uv, y is some another function of uv, we will obtain the double integral in uv plane by using x equal to g of uv, y equal to h of uv. This dx dy will be replaced by absolute value of Jacobian, and integral is with respect to uv, and we will obtain region of integration corresponding to this region of integration in the uv plane. So here you can see in this example, this is the region of integration in xy plane, and applying the given transformation, we can see this region is converted into the rectangular region in UV plane. So we are integrating over this rectangular region. We are not integrating in the region of integration in xy plane. Instead of that, we are integrating over the region in the UV plane. So this is all about this session. I hope you like it.